Okay, here we go. Example 2 from 23B. This is on page 611. We're looking at magazines sold at a store in 1 week, and the data tells us that one magazine was purchased by 23% of the customers, 2 magazines were purchased by 38% of the customers, 21% of customers bought 3 magazines that week, 13% of customers bought 4 magazines, and 5% of customers bought 5 magazines. Okay, question A says, what is the random variable? That's the most important thing you always need to make sure you define and understand. So what is the random variable in this case? Well, it would be, what are we counting? What are we counting? We're counting magazines. So the random variable X represents number of magazines purchased. What are we counting? That's what random variable X is. B, make a probability table. Okay, we can do this. We can say the possibilities that X was 1, 2, 3, 4, or 5, and the probability that X was equal to that little x is 0.23 is 23%, 0.38 38%, 0.21 for 3, 0.13, and 0.05. Okay, and part C, graph it using a spike graph. So a spike graph is just, it's very similar to a column graph, except instead of using columns, we're just using a line with a dot at the top. So we would have our X value across here, and our probability value up on the y-axis. So X could be 1, 2, 3, 4, or 5. And probability, the largest we have is 0.38. Okay, so I'm going to move this over a little. This represents probability. I'm going to go by 0.1 for each of these. That'll allow me some space. So 0.4 is up there. And plot my values. So probability that it's 1 is 0.23. So part of the way up here, put a dot there and just draw a line down to the 1. That's our spike. 0.38 for 2. 0.21 for 3, 0.13 for 4, and 0.05 for 5. And there's our spike graph. That's example 2.